Many organisms within the subphylum Vertebrata use a type of respiration called cutaneous respiration. This form of respiration involves the cutaneous layer of skin or any other interhuman system of an organism besides its gills or lungs. Unique forms of cutaneous respiration have all been found in different species of fish, amphibians, reptiles, and even mammals. This type of respiration works in a similar fashion to how gills on a fish work. The oxygen absorption occurs by way of countercurrent exchange, where the blood circulating through the skin flows in the opposite direction of the absorbing oxygen or surrounding water. This allows for an organism to absorb and have a higher saturation of oxygen in their circulatory system that would otherwise be difficult in a poor oxygen environment. One species of fish that uses cutaneous respiration is the reed fish, which is also known as the ropefish. About 30% of the fish's total oxygen uptake is from cutaneous respiration. The other 70% is from their gills, and they also have lungs. Since the reed fish has lungs, they are able to gulp air for extra oxygen if needed. The combination of their cutaneous respiration and their lungs allows them to live in low oxygen environments, unlike many other fish. The mud skipper is a type of fish that is able to breathe through their skin and the lining of their mouth as long as they're kept moist. These fish are able to keep these tissues moist by bathing in either mud or pools of water. Therefore, if these fish are able to keep their skin wet, they are able to move over short distances of land. The class of vertebrates that is most well known for cutaneous respiration are amphibians, which includes frogs and salamanders. Frogs are able to absorb oxygen through their skin as long as it is kept saturated. They do this by using mucus glands within their skin to keep it moist. They also have many capillaries within the skin, which allow for easy oxygen diffusion. Similar to the mud skipper, frogs also have a respiratory surface within the lining of their mouth. The hellbender salamander has lungs, but they are not needed as it is able to absorb oxygen through the capillaries in its frills, which are located on its head. There is a species of reptile that lives most of its life submerged within water. This species is a sea snake, and while they have lungs, they are able to absorb up to 30% of their oxygen through their skin in well-oxygenated water. Cutaneous respiration within reptiles usually occurs either between scales or in areas that have reduced scales. Another reptile that uses its own unique form of cutaneous respiration is the turtle. Painted turtles in particular use their cloaca. Their cloaca has two different sacs, which are called bursa, and they are able to absorb oxygen without the acidic byproduct. This type of respiration is mainly used when they hibernate at the bottom of lakes and slow their metabolism to almost a stop. Believe it or not, some mammals actually utilize cutaneous respiration. Fruit bats in particular have been shown to utilize cutaneous respiration in their total gas exchange. Studies show that the skin of bats' wings are a possible contribution to the overall gas exchange within the organism, although it is not believed to be very much as their main source of oxygen still comes from their lungs. Since neonate marsupials are born at a very underdeveloped stage, their lungs are not developed enough to retain the needed oxygen level. With their lungs not being able to maintain a high enough oxygen saturation, Oxygen absorption through their skin is required for them to have enough oxygen for development. In the newborns, the large surface area to volume ratio, their extremely thin skin, and their low metabolic requirements all combine to make the skin the primary gas exchange organ. Cutaneous respiration is seen in most classes of vertebrates. Some species have their very own special form of this respiration. All, though, use this form of respiration in order to maintain a good oxygen saturation while in poorly oxygenated environments. These adaptations are only a few of the many interesting and amazing things that organisms can do.